Good evening everyone, nice to see you all. Sorry I've not been around much, busy. I've brought a whole load of gadgets, and I've got some gadgets at home that hopefully I'm going to connect to as well, fingers crossed. But as I was saying to the guys when we were setting up early on, everything has to work, and if any one thing's wrong it's a bit of a disaster. So please bear with me. I'm going to be doing some repetitive typing of passwords, which I am bound to get wrong several times. Please bear with that as well. They have to be long passwords because things are on the internet exposed, so I don't want short passwords. But we'll see how we get on. Most of what I'm going to do tonight is going to be showing you what happens as opposed to showing you slides, but I'm just a couple of introductory slides. So the title, if you like, of tonight was Connecting Home from the Net. And what I was going to do is talk a little bit about what clients and servers are, and a little bit about TCP/IP, the addressing and ports, numbers and that sort of thing, and a few things about some of the applications that I tinker with. And then the advanced stuff, the bottom two pieces, is about encrypted connections from A to B. So that's the sort of thing we're going to do. Now, I'm going to try and keep it fairly non-technical, but it does get technical, so apologies up front. Basically, if we just have a brief introduction to what clients and servers are, for a large extent, you can think of it as a physical computer, a server and a client. But it's actually, the physical box can run many services, and the client can connect to many different servers. So although you can think in physical terms, there's a logical layer as well to it. So what I've depicted here very simply is we've got a server and it has an address, and we've got a client and it has an address, and the server, if we imagine for a moment, is running several protocols, several applications. So in brackets are the port numbers, we call them in TCP. So what you can do on the client side is you can say, I want to connect to the server and his address is, in this case, ending in 100, and then you also specify which application you're connecting to, which service, by saying a port number. And what we do when we do tunneling is we connect one pipe, if you like, between the machine you're at and the machine you're trying to connect to, and then down that pipe you squeeze multiple connections. It's fairly clever stuff, beyond my understanding at the deep technical, but it's really cool, I think, when I've actually figured out how to use it. So that's just a very simple slideshow. That's the slideshow over. Now we get to play. All being well. So what I've got here in front of me is I've got a laptop which we're not going to be doing a lot with, but that's a Linux laptop, and I've got two Riscos computers over here, these blue boxes, the A9 Home. The one that you see at the moment is going to act as the client, and I've got a switching box between the two, so I can do something like that. And what we've done is we've switched the keyboard, the mouse and the video to the other machine. And it's so you can see that up there as well. Because it gets very confusing very quickly, they have a very obvious backdrop on the screen. So that's the server, and it's running some things down here, which we'll come back to in a minute. If we switch back to the client, we've got some other things we're going to run. So you've probably all seen NetSurf, web browser. We'll be using that shortly. But first I'm going to talk about VNC. VNC is a remote control utility. It lets you sit at one computer and remotely see the screen and control the keyboard and the mouse of another computer. It stands for Virtual Network Computing. And as with the title of the talk sort of thing, connecting from A to B, you know, into home from the internet, we've got clients and servers. So I'm sat here with a VNC client, and this one is called Avalanche. And what that lets me do is talk to a server which is providing the remote screen and taking the keyboard and mouse input. So all being well, what I'm going to do is connect from is actually this physical box to that physical box through this black router. So just a local area network at the moment. Now the way I do that is I need to know the IP addresses, which is why I have that on the slide. Every computer on the network has an address, so there's a command you can use to find out what that is. If config, that stands for interface config, and if I do -A, it says show me all, and here I've got something called EX0, and it has a number here. So that is the IP address that the client machine here has. And if I switch to the server, and we can do the same thing, it has very much similar output, but this time the number is different. It's 10.0.0.100, so that's the server, and we want the client to connect to him. The client is 101. So what we type in the connection box here for VNC is we say connect to 10.0.0.100, and if you all cross your fingers, this should work. Magic. So what that's done is it's made a TCP connection from one box to the other box. It's talking in a particular language or protocol, which is the VNC protocol, and the server won't let me in until I type the password. It's some security, but it's limited. The VNC protocol is all clear text passing of information. There's no encryption by default. So on a local area network, that's not a problem, no worries. If you're going across the internet, that would be a concern. So even the password that I type that you won't see will go across this little network in clear text. So it's accepted the password, and it's updated something in the window. So if we just make that full screen, hopefully you can appreciate that that is the server, the view of the server, as viewed from the client. Are you following me so far? It gets confusing really quickly. Okay. Right. Now, the Riscos server that is providing me this view, this screen, and taking my inputs of keyboard and mouse is fairly crude, rudimentary. It's not very well refined, so it's slower than you might find on Windows or Linux. But because it's the VNC standard, they are compatible. So I can connect from Riscos to Linux to Windows, I can connect from Windows to Riscos to Linux, and so on, all the way around every connotation. Excuse me. There are client and server programs for all those platforms, Mac as well. So we've got the VNC server, but because both machines are a similar resolution, it's hard to see them. So what I'm just going to do, if I menu click on the bottom bar here, then I get this Avalanche menu. Avalanche is the VNC client. I can say scale to window. Now, what that's done is it's getting the full resolution signal down the network, but it's squeezing it locally to scale it into the window. That is a useful feature, because although you can't read the text at the bottom there, you might not need to for some particular purposes. But if I click here, you can see that I'm operating that remote machine. And you can see there's a bit of a delay while it catches up with the redraw. That's dependent on the network, which here should be pretty quick. It's 100 megabit per second here. But it's also dependent on the protocols, and as I say, the VNC server for Riscos doesn't have the efficiencies. A lot of them now do compression and do optimizations with the traffic that's going back and forth. Unfortunately, we don't have that in the Riscos server. Avalanche, the client, can do compression. So when it talks to a Linux or a Windows server, the experience is a lot more rich. It's faster for a given network. But it allows you to connect into a machine that you're not physically present at. The connecting from home theme to tonight is why I do this. I like my toys, but actually I found it really, really useful sometimes when I'm away from home working and I connect over the internet to a machine at home. Now, there is some infrastructure at home I'll talk to you a bit about in a second that allows me to do that in a secure manner. But we'll focus on the local for the moment. So we've got an application where I can see the screen and I can control it. Okay. You might be able to read that. I can say don't scale, and then I can pick a particular scale with Avalanche. So I can say scale it back to 100, and it doesn't fit on the physical screen, but you can see that's the correct size now. Just to prove I'm not cheating, I don't think you think I am, I'll switch to the other screen, and there it is. And you'll see that that's the actual screen you're looking at now, as opposed to a remote transferred representation. Okay? Following me so far? Okay, gratefulness. Now, the VNC server is implemented as a Riscos module. There it is. But it's a little bit horrible to use. It's basically just some commands that you would type. So a long time ago, because I thought this was a really cool utility but was a bit difficult to use, I wrote this front end. Excuse me, it's written in AppBasic, and it's got a menu, it's got a window, and it allows you to set up some choices for your server. The beauty of this is, with my front end, I can put that in the Riscos boot sequence and have it automatically start. And because my program, when it automatically starts, if I tick this button, then it also launches the VNC module and sets up the connection to listen. So all that can happen automatically, if you like. So I can reset the computer. Even remotely, I could issue a reboot command if I knew what command to issue. And as long as I wait a minute or so while it comes back up, the machine's ready for use, and I don't have to worry about, oh shucks, I forgot to type in the right command before I left home. Yeah? So I've got the VNC server front end that I wrote in my boot sequence, which means it comes up every time. And that's one of the value adds I put in the front end. I've actually had an email today from someone asking would I mind if they distribute this, and I've exchanged a couple of emails with them. It is free. I was asking for donations, but it's totally voluntary. I've developed this over quite a few versions. I don't know what version it's at now. 203, right. Obviously there's not been 200 on, but there's been a fair few. And what it does is it saves these settings. You'll see at the top there, there's 5900, and it's greyed out. All these protocols, as I said on my slide, have a particular port number. VNC's is 5900. So what we see if we just get rid of that. So we're still on the server here, but if I type a command, inetstat -an, that gives me some statistics about the internet stack on the server. And what we can see here is there's TCP connections and UDP is another protocol, which we don't care about right now. But you can see this line here, TCP, and there's a 5900, which is significant. And you can see also over here that it says it's listening. Now, part of the VNC server front end, if I right click that. Hopefully you've seen it's gone grey, it's less clear on the projector. If I repeat this command that I just did, there's no longer a 5900 in the list. I've killed the server, effectively. If I right click it again, it goes blue again, and we've got 5900 back again, and it's listening. So that literally is stopping and starting the server that provides this VNC stuff. And obviously if it's not listening, it won't accept the request from the client to connect. So you don't have to run it, you run it when you want to, whatever you need to do. So if I switch back now to the client with the keyboard, it was still connected while I was doing all that, but because I stopped the service, Avalanche has errored, if you like, and said, hang on a minute, the server's gone away. So it's dropped the connection, and it literally says it was dropped by the server. But having restarted it, I should be able to connect again, and sure enough. So, there we go. I'll tidy the screen a little bit because it's gets cluttered very quickly, doesn't it? Right. Okay, I'll just go back to the server now for a moment. We'll explore VNC a little bit more. Now, the module, the underlying module that provides this service, gives a few rudimentary functions. You basically start the service by telling it what port you want it to start on. So my front end says, well, it needs to be 5900. But you can, if you want, start it on a different number if you want to be a little less obvious about where you're listening. The module that underpins this also allows you to do a view only. So if you don't tick allow mouse and keyboard, then it ignores any input, but you can still remotely view a screen, which might be what you want for some things. And also the module allows you to swap the right hand and the middle mouse buttons within its context of listening to key presses, mouse presses. And that's because for a long time there were many PC mice out there that only had two buttons. And sometimes you need that middle button, which, you know, for RISCOS is pretty key. Well, when you've got a two-button Windows mouse, it doesn't implement the middle button. It only implements the left and the right button. So, because of the possibility of somebody only having two mouse buttons, this function exists. So it's in the underlying module. All I'm doing is setting it up or not, as according to the choices that the user's configured. In order to listen to a connection, you have to specify a password. So in the command line that my program runs, it issues the password, and that's in clear text. However, on the dialog here, it's obfuscated, just with the standard RISCOS template that lets you do that. So what I do is I store that password away along with the other functions, configuration options, and I store those in a choices file. And if we have a poke inside the boot, choices, we have this file here which has been saved by the front end. So fairly obviously auto run is start automatically, default port is true, which means that's grayed out, the port number is 5900, and so on. The password, however, isn't that. It's a very crude encryption, so you can't guess what it is. So it's still got to be decrypted, if you like, in order to issue the command to the underlying module. But as far as storing it, this was something that I wanted to do from the outset with the front end, because although I wanted to automate everything, I could do that in an obey file script. I didn't want to store the password for the server in a script in clear text. So I did that early on. For any of the hackers out there, you would be able to crack it. If you've cracked anything at all in the past, you'd be able to crack it dead easy. but I'm not going to give any clues away. So, simple choices file. When the front end starts up, it loads that choices file, reads them in, sets the appropriate things, launches the server. Any questions on the VNC stuff? Because I'm going to move on now. Okay. Right. Hands up if you've heard of Telnet. Right, okay. Hands still up if you know what it is. Right, okay. Not so bad, okay. Right, so Telnet is a terminal emulation. So again, it's client server, and we have a listening server, and in RISC-OS we have that in the form of Eagle. There's a guy who calls himself the Flying Pig. I can't remember off the top of my head what his name is. He's written quite a lot of very quality software. This simple Telnet server, as he describes it, is a simple Telnet server. It's reasonably functional, but it is lacking in a few areas, and he acknowledges, you know, that it's limited. But it's well worth having if you want to connect to your machine at the command line level for a little bit of stuff. I'm going to demonstrate that in a second. Another important thing to know, like VNC, Telnet is not encrypted. Use it at your own risk. Okay? So we're on the server, I'm going to jump to the client. Because what we want to do, I'll kill that VNC connection. There's a program called Nettle. Who's heard of Nettle? Right, okay. Nettle is a terminal emulator program as a client. So I can use Nettle to make a connection outbound to a Telnet server. So the way that you do that is, excuse me. So I want to connect to the same IP address, but inherently all these programs that you use to do these specific functions know what port number to go to. If you use the non-standard port, then you need to specify it, and it's often you specify a colon and a number, or sometimes it's a space. But for the Telnet protocol, it's port 23, and hopefully, yes. So, there is no visual on the server side for this. If we jump back to the server side, the fact that I've made a connection, there's nothing changed on the screen except down here on the icon bar, that's gone sort of yellow and orange to show there's a connection. Okay? If I jump back to here, and I will just open up the VNC again so that we can see both screens at the same time. This is where VNC gets quite useful. But what I'm going to do is I'll scale that down, scale to window. Right. Can anyone not see the fact that there's an orangey yellow splodge there? Right, you can all see that, good, okay. Right. I right-clicked the orangey yellow splodge, which is a function of the front end, which is where I got my idea for right-clicking my front end, and it stopped the server, which promptly caused disconnected on the Telnet session. And if we try and reconnect that, it will fail, he says. Why did it not? That's reconnected. Sorry, let's try that again. I'm not used to things failing by working. I can't follow that, sorry, that shouldn't work. Let me just jump back to the server. Ah, right, it's a two-stage thing. Right, can you see the icon is a wire that's been broken? What I'd been doing was, that's connected, ready to listen. And when it was orangey yellow and I right-clicked it, it just threw off the current connection but didn't stop listening. I had to click it twice to close that. That's what was going on. So back to the client. We've disconnected because it's stopped the server, and this should time out now. Alright, it's been refused, okay. It's positively said, no, there's nobody listening there. So if we just right-click that, and we try again. Woohoo! Right, so I've got a user on the Telnet system. You have to log in as someone, so it's implemented single user, and I've called the user Riscos, and I've given it a password of Riscos as well. So we now have a command line prompt, which is a Telnet connection, command line, to the server. Now, the reason I've got the VNC window up is I'm going to do a command via Telnet that opens a window on the server. So you could do this locally, and I'll just show you that. Local, filer, open, dir, resources, $apps. Okay. That's the same as clicking on the apps folder down there. Right, if we do that same command in Telnet, no prizes for guessing what should happen. Except I mistyped it. Open dir, resources, $apps. Cool, isn't it? Sorry, I need to get out more. And obviously the reverse is true. Filer, close, dir, resources, $apps. Now, can you see I've mistyped? I've got 4 and $1. That's one of the foibles with the Telnet client. I have actually deleted it, that number 4. It just doesn't show. So it's not a perfect implementation, but we can do pretty much anything you can do at the command line via Telnet. Start help, start ROM modules. So I've got access. I can even do the command. Oh, you can't see that, sorry. VNC serve stop is the module command to tell the VNC server to stop listening. And if I press enter, we're going to lose the VNC server. It takes a second or two because Avalanche doesn't realise straight away. But there, it's dropped. Now, what I've also caused is the fact that I can't reconnect because I've stopped the server. So trying that will just fail. Okay. Now I could switch locally to the server and fix that by turning it off and on again. And if I switch back, then magically we've got a connection again. But what if I'm in London and the server's in Leeds? So that's why I've been running the Telnet client. The VNC server module on Riscos isn't 100% stable. It drops connections, it dies, it misbehaves. It's been good so far this evening here, but it's not dead rock solid. So having another way in via Telnet that can start the server up again is quite useful. So we do that VNC serve stop. We'll lose the connection. I'm preparing to start it again. The command that my front end issues when it's trying to start the server is literally just this. VNC serve start, the port number 5900 and the password I'll put Riscos. And we can see that 5900 on the server is listening via the Telnet session. So if I now try and connect again, we're in. Are you still with me? Right. I use VNC an awful lot at work and at home. For work, I've got the office down south in Bracknell, and I work from home in Leeds. Now, I don't use Riscos very often for work, but it's all these same concepts apply. I remote into the office and I can remotely work on machines that we've previously set up to listen. So VNC is just a really brilliant tool, I think. It's a shame the Riscos server isn't a better quality one with more features and refinements, but it is functional. On a local network, as you've seen, it's reasonably quick. You can work with it. So if I, for instance, load draw, just to give you an idea, you can see there's a slight lag, but it's doing stuff. So local and area network, not a problem. Right. So we'll kill that. No, we won't. We'll scale it to screen and make it small. Right. So that's Telnet. And if I log off, oops, can't type. There we go, disconnected. Any questions about Telnet? No. It's fairly simple. So if we just have a quick look at Igor, you can set up what port it listens on, you can give it a username and password and save those details. It's that simple. Right. Who's used FTP? Right. File Transfer Protocol. We have a Riscos client, which is called FTPC. For some reason I didn't pin that to my background. There it is. Save. Now, I think I've left it running on the server, but we'll see. Yay! Okay. The VNC and the Telnet client, compared to the FTP client, are about the same level of complexity, refinement. They're all pretty basic. There's not a lot to them. So if we have a quick look at the server, can't actually remember where I put it. Nope. There it is. So there's a list of users in there. There's a root user and an anonymous user. You can add your own, and it tells you what folder they log into. So here it's public.ftps, and if I jump back to the client, we can see two files when I logged in. And I'll just create a folder. And it didn't let me. The reason it didn't let me is because I'm logged on as anonymous. I forgot about that. I can't remember what password I set up for the other user. Possibly it was Riscos, so we'll try that. So user root password. Let's see if that works. Okay. Right, it's done it this time. Yeah. There we go. Right. So if we jump back to the server and have a look inside public, we've got an FTPS folder, and those are the items. Right. Okay. So what we can do, fairly obviously, is we can transfer files using FTP, and Riscos FTPC has implemented drag and drop, and it was as easy as that. Okay, So we have a basic FTP server for ISCOS. Again, FTP, it's a legacy protocol, it doesn't do encryption. Be aware. Your passwords are in the clear when you connect up to these things, okay? So, I bet you're thinking, well, why is he telling me all these useless applications that I can't use over the internet because none of them are encrypted? Well, that's where the tunneling comes in. So, before we come on to that, just very, very briefly, we also have a web server for ISCOS. Again, rudimentary. I've copied down off my public website a few of the files that make up that site, and I've put them on this box, and that is the 100 address. So you see a bit of a flavour. So there is a server for ISCOS. It's called WebJames. Some of you may have heard of that. There's no icon, no interaction on the icon bar for WebJames, but it does live in the task manager when it's running. The way that WebJames works, very briefly, is you run the application, there it is, and inside it there's some configuration files. It's reasonably well documented. I've not become an expert user, I've only tinkered with it. But basically one of the things it does is it points to where the where the site lives, which is where the application is, up a folder, and then in the folder called site. And if we look next to WebJames, there it is. And as I say, I just copied a few of the files, so we have a look at. Sorry, I didn't have NetSurf loaded on the server. There we go. So that's the local version, and if you look at the title bar, sorry, the address bar, it says file : / etc. Whereas if we look at the client's view, it was a proper HTTP request that took place. So we've got FTP, we've got web, we've got telnet, we've got VNC, we've got a selection of things that you can interact with and set up servers if you want to. Particularly locally at home on your own network, generally not a problem security-wise. Now, what we don't have, as far as I'm aware, is an SSH server for ISCOS. SSH stands for Secure Shell, and it's something that was born in Linux, I think, or Unix, thereabouts. It's become a standard, so you can get SSH on Windows, Linux, Macs, and there is a client of sorts for ISCOS, which is what I wanted to attempt to do over the internet tonight. Because I don't have a server here for ISCOS, I can't do that local test demonstration. So the moment of truth now comes. I'm going to pop out a cable and try and connect to the internet. Now, the client that we have for doing this stuff is even more rudimentary. Which cables am I pulling out? Sorry. Just make sure I get the right one.
You're asking me?
That one there, that's the server, that's the client, this one here. So what I've just done there is I've disconnected the client computer, which is what you see there, from this router and that machine, and it's going directly onto a cable for the internet. Which means that its IP address will change. Oops, I've just knocked the camera over. I've killed the camera, sorry.
Sorry?
You need to look what you're doing while you... You need the cable if you need to. Sorry about that, folks. Edit this without, can't you? Yes. You could test it to your heart's content at home within the limitations of WebGames functionality. And then you could upload it to a real server, yeah. I'm sure people have used it for exactly that.
Yes.
Yeah. It can serve out onto the internet if you want it to. That obviously comes into the realm of how secure do you feel it is and all the rest of it. But yeah, people have done that.
Yeah.
So. Okay. Sorry, I've caused trouble all evening.
You haven't got your Bluetooth.
What chewing gum?
I don't like this game anymore.
We're managing with that.
Is something going on here?
I have exactly the same trouble with some cameras at home.
What to do?
Right. Okay, so having connected the relevant cable to give the client computer an internet connection, I now have a different IP address. I don't really care what it is, except for the fact that I do to make a special tunnel connection. But we'll come on to that in a moment. So just close those out. I'm just going to go online and double check that I can go somewhere. So Wikipedia, as good as any. Except it's a bit slow. Try something else. It's fetching, it's just taking a minute. There we go. Right, Risco starting. Okay, so we're online. Now, hands up if you've heard of something called PuTTY. P-U-T-T-Y. Brilliant, okay. I'm going to be using PuTTY Tools. Somebody's ported PuTTY Tools to Riscos. I don't know what PuTTY actually stands for, but I think the TTY is related to the old sort of terminal emulation. Yeah. Do you know, I'd never thought of that one, really. Very good. Yes. Yeah. So, there's a very popular PuTTY client program for Windows. Somebody ported it to Linux. I don't know if it was the author or somebody else. And along with the sort of Windows GUI graphical implementation, there's some underlying tools called PuTTY Tools. One of which is called P-Link, or Blink, if you prefer. Well, I always say P-Link. And what that does is allow me to make some connections. So I've got something here which has got a few commented outlines. The green lines are commented. But it's a P-Link command with some parameters which I'll explain in a moment. So, hopefully, if all my hardware at home in Leeds hasn't crashed while I've been here, I'll be able to connect up. So, let's give that a go. But because I'm on a different internet, because I've had to do it differently, I'll have to modify things very briefly. So, when I said I didn't care what the IP address is, that's an old one. I do. That's what I care about. So, it would be really nice if this one works. I'm going to paste that into there, delete that old address, leave that in there, leave that in there. Right. I'm not going to explain that for a moment, I'm just going to do it, because if it doesn't work, I'm wasting my breath. So, let's give that a bash. 2.168.1.186. Right, everyone hold your breath. Okay. This is where the fun starts. iNetStat is such a useful tool for debugging internet connection trouble. Right. That didn't work. So, I'll start to explain a little bit on this. Out on the internet, I've registered a name which is sshDemo at sshDemo. Well, sorry, the bit before the at isn't internet related. That bit is. I've registered a dynamic DNS name that should be pointing to my server at home, and it's that. So, let's just see if that works. sshDemo.dhcp.biz. Right, that looks right, okay. So, let's run that and see what happens. Ah! I forgot to step, that's why it didn't work. Right, let's just close this down. This window here is P-Link running in an obey window, and it's connected to this sshDemo.dhcp.biz. Sorry, yeah, I keep forgetting. Right, it's connected to that that's highlighted, and it's trying to log in as sshDemo username. So it's asking me for a password, and the fact that it's asking for a password means it's talking to it. So now this is when I'm going to start making mistakes typing passwords. You won't get to see the password no matter how much you put down there. Right, that was the password and all those keystrokes, and it's bound to be wrong the first time. Access denied, there you go, you see. Hey, we're in. Right. Now, the infrastructure that I've connected to is actually a Linux box, because, as I was saying, we don't have a RISCOS SSH server, so I can't use RISCOS to sit and listen. But what I can do is have Linux sit and receive that connection, which is what we're now connected to, so I can do things like that's a horrible Linux command. I'm actually using a secure shell connection, which is similar to Telnet, but is encrypted, yeah? So I'm connected to a machine in my bedroom at Leeds. And in addition to having connected to it and authenticated with the username and password, the P-Link command has made a tunnel to allow me to send other connections from programs here to listening programs in Leeds. And they don't need to be on the Linux server. They can be redirected from the Linux server that's listening, that's made the tunnel, to one of the other computers in the house, which is what the beauty of it is. So effectively, the Linux box that I'm currently connected to is like a gatekeeper, for want of a better description. And what I've done is I've made a tunnel to a gadget, which I'm hoping will work this time. Cross your fingers. It's worked. So I have a gadget in my lounge on the network, which is streaming video. Now, hang on a second. That is BBC News 24 live. Over an encrypted tunnel from here to Leeds off Virgin Media, my set-top box. Now, I was holding my breath somewhat there because My set-top box is one of these TiVo things. If you leave it switched on for too long, it puts itself in standby, so I didn't actually know when I connected to this whether I'd get the picture or just a black screen. So thankfully it's working. Now, the gadget in question has 4 channels that it can receive composite video on. So I've got a composite video cable from the Virgin Media TiVo box into this box of tricks, and it is on this channel 1, if you like. I can listen to other channels, and I don't know whether that's one that's in use. I've only got 3 things hooked up, so I'll try channel 3 instead. There we go. Right. I've got a cheap little Legacy Games console. It's a little box about this big with a great big joystick in the middle and 2 red buttons, and it's got Pac-Man and pole position and a couple of other things. So, but it's battery powered. So I've had to switch that on last thing before leaving the house and hope that the battery didn't run out. And it hasn't, so as you can see. I'll turn that other channel off. And I'll turn News 24 off. Go away. Right. So, it's waiting for me to press the fire button, which obviously I can't do remotely. And then the 4th channel is hooked up to a DVD which I've left on. Unfortunately, all the time I've been here, I left it at the main menu, and it would have played through the entire film, streaming it to nobody, and then it's come to the end and it's gone to, right, well, you've seen the movie, what about the extras? And it's waiting for me to choose an extra, so there's no animation, I'm afraid. It took us so long to get going, we've missed the film. But anyway, my backup plan was News 24 and the Namco Games console, so you get the gist.
Are you going to open the ports on your router?
Yes. Now, what you could do is open lots of ports on the router for each of these individual applications that I've been playing with. But that leaves you more vulnerable. So again, the tunneling, which as well as being encrypted, means that you only open one port to let the tunnel through, and everything else squeezes down that one port in the tunnel. So if you remember the slide I showed earlier on, I'll do it. I'll find it now. Normally, each one of the connections on the right would need, a separate channel, if you like. But what the tunnel is doing is, the tunnel is the one connection, and it happens to be port 22 by default for secure shell. And then what you do with the P-Link tool that I've just run is you tell it to make a tunnel and squeeze the traffic down. I haven't figured out how you do P-Link multiple times, so I can't do more than one at once with P-Link. I think it might be a restriction, but I've not done enough research.
It's encrypted then?
But it's encrypted. So everything that we've just seen on the video, that's now dropped the connection, so it's failed. All of that was coming across an encrypted tunnel that P-Link had created. And if you see, we've got broken pipe there. So the connection dropped. But I can do it again, in theory. P-Link, because it's encrypting, it takes a few seconds before it connects sometimes. That was relatively fast, but sometimes it takes a bit longer. First time, yay! Right, so we can run that again if we need to. But that's not very interesting, so we'll go back to channel 1. Broken pipe again. Let's try that again. I wanted to show a feature of this thing, if it works. No, I've done that wrong. Okay. What you see now is the live TV, and the speed of this is dependent on the bandwidth that you've got available, plus the RISC-OS processing of the encryption, etc. The gadget in question can let me drop the resolution. So hopefully that will change. There we go. So I've made the picture smaller. Sorry, it's off the edge again. And therefore we're getting a slightly higher frame rate. Now, over the internet, to a RISC-OS machine, that's not a bad frame rate, live TV. And I can tweak the quality settings. All this stuff you're seeing on this window are features of the box of tricks, and there's some RISC-OS software that was written to use it. Now, I've left that playing long enough that it's probably worth showing this feature. I can pause it. I can step back through the frames. I can step forward through the frames. I can go to the beginning and step forward again, and so on. Now, I can't save that video stream as this program is, but what I can do, when it's paused, I can steal a picture from it. Just like that. So I've got the ability to capture frames from live TV effectively, or any composite video source. In a similar vein, and I don't know whether this will work, I've got another gadget which I'll come on to. Am I alright for time? Yeah. We'll come back to that one in a moment. What I'm going to do is lose that. I'm going to make a different P-Link. So I'm going to comment that one out, and I'm going to put that one in. It's going to the same internet address. I need to put that local address in here, because I'm on a different local network now. But all the rest should be okay. Then if I run P-Link again, the reason it's in a file is just to save me having to type it all in. Oh, yes. Sorry, need to get out more.
Try chasing some Pokemon.
Yes. I've forgotten the address already. Right, so I'm going to do a VNC connection over the internet down the tunnel, just to sort of complete the picture. So, what I haven't explained is the address that I'm typing in to connect to these things, which I shall do so in a moment. Let's do that out. Yes. That's a RISC PC running RISC-OS 6, sat in the on the desk in the bedroom, sort of thing. So it's got the Telnet backup, it's got the VNC, etc. It's my main work machine. So just like you saw earlier, I can do local manipulations. I'm doing exactly the same thing. It just happens that I'm sending it down an encrypted tunnel to get there. So, the gadget that we saw the live TV on is a separate piece of kit to the RISC PC. They're not at all related, they're just sat on the same network. So, they have a different address, which is the second IP address here. So, the RISC PC is that, the video box was that, and they've got different port numbers because they're running the different protocols that listen on the different port numbers. The number up front here is the command to P-Link of how to connect. What P-Link does is it creates the tunnel and it knows where it's terminating at the far end by the second number, which is the actual machine I want to connect to, not the tunnel end, but the actual RISC PC or the video box. But in order to get into the tunnel at this end, I have to do it on my local computer, because where else would I connect from? You know, I'm here, it needs to start here. So what P-Link does is it creates a special connection that is locally listening on the machine here, and anything you connect to and send down to that listening connection just gets redirected down the tunnel and pops out the other end. And it's a bi-directional tunnel, so any data that's returned you get. But you have to specify your local address in the command. So what you're saying is, the -L is saying, connect a local address tunnel from me on a particular port number to the remote end in the other network as follows, and establish the tunnel by authenticating this user at this internet address, if that makes sense. The only bit I've not explained is the -P2000. And the P is for a port number, and the 2000 is port 2000 on my router, which is the listening port I've opened on the router. Normally, Secure Shell would be 22, but 22 is an obvious target for anyone looking for such things. So I've chosen 2000 for the purpose of this evening. And what you do is you log into your router's web interface and you say, I want to do port forwarding, and then you can basically set it up. So I've got port 2000 on the external interface of my router is forwarded to a particular Linux box in the network to port 22 on that Linux box. And that Linux box is running the SSH server. And anything that hits port 2000 on the router gets passed to the Linux box, and then it does the appropriate tunnel termination according to P-Link. Hopefully that's clearer than mud. It's fairly technical in nature, this stuff, and it did take me a while to figure out all the intricacies to get it working.
So you've got your router connected to your Linux box connected to the RISC box?
Yes. Yeah. So the Linux box and the RISC PC in my home network are equal peers. No one is greater than the other. They're sitting on the same network subnet, we call it. They're both just sat behind the router, and they both have an address of 192.168.21
So you've done that just because Linux would recognise the program rather than...
Sorry?
You've done that because the Linux box would recognise the...
Yes, the Linux box is doing the encryption tunneling, yes. Because we don't have that facility on RISC OS. Yeah. So the other entries in here, I could telnet to the RISC PC, but I think you've seen telnet, it's not exciting. I'll just briefly connect to the Linux box to show you that RISC-OS will talk to Linux quite happily. So I just need to comment that one out. Remind myself what this one is. Right, it's that one. I need to copy the 192 address to here. As long as you know what all these addresses are, they're arbitrarily chosen, but you need to know what they all are and who's which, basically. Right, so let's give that a go. Now, the connection is still valid there, so I need to drop it with exit, and that's gone. Now, if I run the P-Link thing again, that should now tunnel to the Linux machine. Feedback. Start that, yeah. And you're in a finger trouble. Right, I've failed too many times, it said go ahead. So I just need to run that again. Well, hopefully if I'm finding it difficult, so will an attacker. That's my theory. Right, okay, so what we're going to do is, in essence, I've been doing this all evening since we've connected to the remote machine. I'm connecting to myself implicitly on 5900 because that's the VNC program's protocol. But this time the tunnel is pointing somewhere else. It's pointing at a Linux machine. And it happens to be Linux Mint. So that actually is the big beastie that's doing the tunneling for me, that I've connected directly to him. So although he's handling the tunnel still has an instruction to terminate on an IP address. The fact that it's the same physical box is irrelevant. You've got a tunnel, it terminates somewhere. It just happens to be the same box. It's a fairly powerful Linux box, and it's got 6 processor cores and lots of memory, and it runs multiple virtual machines because that's what I play with basically. I do use them for various things, like one I've got for web browsing. The one that's actually doing the tunneling is a virtual machine rather than a physical machine, so it's this guy here, which, just for fun, is not Linux Mint, but is Lubuntu, the light version, so it looks a bit different. But yeah, I don't know whether you can appreciate that the speed, this is over the internet, down the tunnel, 2 leads, the speed of the Linux VNC server is faster than the Riscos VNC server. It's even, I think, slightly faster than the local that I was showing earlier. And that's because Avalanche, the client on Riscos, is still happy to talk to the more advanced servers that do the compression, that do the efficiency. So they do literal compression where, you know, all these bytes need to get smaller, but they do things like, well, if that part of the screen hasn't changed, don't transmit it. Whereas the Riscos server is saying, all this big screen, I've got to send each one of those dots. So it's highly inefficient. Yeah. And that's where we could benefit from somebody spending a bit more time on it. That's pretty much all the toys. I do have one local toy, which I'll just have to move a cable again. And we're probably alright in here. So what I'm going to do is I'm going to drop this tunnel. I'm going to try not to knock the camera over. So that's coming out, and that's going in. I'm going to check my IP address. Okay. So we're on the local router here again. And something's not working. This might take a minute or so. It might not work at all.
What is that doing?
Not telling you. You can't see it yet. It might not work at all. It's a little bit temperamental sometimes when I mess with it. Sorry. I thought that was still in.
See,
Yeah.
try to.
Yes, you're right. My mistake, my apologies. Right. Yeah, I've got another box of tricks here. It takes a while to wake up sometimes, so. And I get impatient and turn it off and on again. Sorry, power cycle it, right? This program I've been using comes with this gadget that's on the desk, and it comes also with the gadget that's Leeds, which was doing the video streaming. I'm getting impatient now. Should be working, don't know why it isn't. No, on the address 10.0.0.255. So 255 is a broadcast, so I've just sent a ping to everybody on the local network to see who replied, and I've got a reply from 200, which I know is the router. I've got a reply from 101, 100 and 102, so there are 4 devices there. One of them's myself, so I'm 101. So I think the server is 100 because that's what we've been doing before. So it should be 102 that I'm looking for. So let's just try and do this. 10.0.0.102. Still nothing. Okay. It might wake up in a minute or two. It usually does when I get bored of waiting for it. Right, I'm going to reveal what it is. It's a camera. It's a webcam. So in theory you're all on TV now, but it's not connected yet. Not quite sure why.
Hold it in front of the camera.
Sorry. Yeah. Sorry? Yes. Yeah, that's exactly what it is. It's called an IP camera. And I got them ages ago, this and the video streaming box. So they've come from Stuart Tyrrell Developments years ago when they wrote the software, and not quite sure why it isn't connecting. Oops, cancel that. Well, we'll leave that there for a minute or two, it might wake up. Any questions? Have I completely baffled all of you and bored you to tears? Sorry.
I've got something.
Oh, magic, thank you very much. I knew it would do it when I gave up waiting. There we go. Woohoo! So. Oh, right, hold on. Yeah, it defaults to top left. Right, there we go, let's make it bigger. Well, there's a focus ring on it, if we can do that a little bit. But we can turn it the right way. So, they are reasonably old cameras, so they're not as good as modern lenses and all the rest of it, but you get the idea. It's not so bad in decent light. In dark light it's not fantastic, but it's pretty good, and in daylight it's very good. I did have one of these set up on my windowsill looking out at the garage roof when I had some guys re-roofing it. And well, partly, but inside the firmware are all sorts of features which are represented here. So you can do things like motion detect.
That's the thing.
Yes, if you like. So I had it set looking down at the garage roof, and the garage was directly outside, so it was a reasonable view. And I had motion detect on the garage, and you can pick your zone that you want to detect motion in. And then I had it FTPing the motion detected frames to a local FTP server, and you got all the stuttered frames, and then I used a processing program on Linux just to put them all together because they're JPEGs, make a video, and I got guys breaking off all the old felt and putting down the new tar, and it wasn't perfect, but it looks reasonably good. I haven't brought it with me because I've misplaced it, but I've got it somewhere. But yes, it's quite a useful little tool. But you can do things like, if the camera supports it, you can change the brightness. There you go, so that fairly dramatic. The colour cast hue sort of thing. This device doesn't support contrast, but I think the video streamer does, for instance. You can saturate or not. Sharpness. Sharpness does what it sounds like. It makes the picture a bit sharper, but as a result of it being more well defined, the bandwidth drops a little bit. So you can play it off between the quality of the JPEG encoding, the resolution of the picture, and the sharpness. Somewhere in between, you get what you're after. Hopefully you could see that when it's at maximum sharpness, you see a lot more grain there. And if I knock it down here, it's a lot less grainy, but slightly more fuzzy. So, yeah. Anyone that knows me, and probably even those that don't know me so well after today, know that I like my toys. So, yeah. TCP/IP, Internet protocols, brilliant stuff. Inbuilt, brilliant. So, thank you for your time.
Yeah.
That's pretty much everything.
Rock, helping you with Acorn and Riscos computing.